Hey, it's me. Okay, thank you so much for having me. This is absolutely wonderful. I'm thrilled to be here today. And I will be speaking about serverless computing. Now, I will not talk about serverless computing like what you normally see in AWS with their functions or Google Cloud or Azure. I will speak about you setting up a system where people in your company can use serverless computing, right? In your clusters, specifically in Kubernetes, because everything is Kubernetes today, right? Now, to make things interesting, I will focus this talk, this solution on CNCF projects only. Open source, cloud foundation, free for all, everything. So all those tools are the CNCF tools. And CNCF is awesome, right? So I will try to be very quick today because, why? Yes, because, hey, I have 30 minutes and I want to leave as much time as possible to questions, right? So ask questions and Saim will propagate it somehow to me and I'll do my best to answer all of them, right? Now, let's get going with that right away. No time to lose. And there we go. This is me. You see me on the screen. I don't know why. Yeah, you don't see me in the slides. So let's put on the slides. Saim, can you put the slides on? There we go. Hey, so serverless computing, right? Now, serverless computing, many people think that serverless computing is all about serverless functions or this or that. I tend to have a simpler explanation. That's serverless computing you can define by saying that it's a mechanism or a tool or a platform, let's say, to enable people to say, here is my source code. This is the code of my application. You do everything else. Don't ask me any questions. Don't ask me why, what, how. Here's my source code. I want you to build it and I want you to run it, right? Don't ask any questions. And as a cherry on top of that cake, I want you to go up and down depending on the load, right? So if there are more users on my application, I want it to go up to increase the number of replicas. And if there is less, I want it to go down, right? Now, today I will use, let me actually switch to my screen. There we go. That's my screen. I'm a terminal person. I like terminals more than anything else, almost as much as my daughter and my wife. So here's the source code of one of the application I will want to deploy today, right? This is called Open Function. Open Function is yet another CNCF project that combines quite a few other projects. It combines Knative to run it as serverless, to scale automatically and what's not. It uses Dapr to connect automatically to your database so that you don't have to think about it in your source code. It uses Shipwright to build your images. It combines quite a few other tools, puts them all together and makes everything relatively easy, right? And I, as a user, all I have to do is define this 20, maybe 30 lines of YAML, where I'm saying, hey, I want to run my application as a function. It's actually a very, very bad name. This is not a function. This is serverless, right? Because functions are something very different. And I want my application is packaged as a container image, or what you might call Docker image, and that's where it is. Here we go, right? And these are the credentials for my registry, so that you can pull that image. I want you to build. Actually, now this important part. This image does not exist. It does not exist anywhere. I did not build it. This is not an existing image. This just says, why don't you build that image for me and push it there, right? So that's why it's called the push secret as well. And I want you to build it from my source code using this builder Go, because this application happens to be in Go today. This is the source code of my repository. So take the source code from that repository, build the image, and using Go and push it there, right? And I want to enable Dapr so that my code does not even know that there is a database, right? Dapr will do the magic to figure out where is the database, how to connect to it, what's or not, right? And my application is working on port 88. It might seem too much YAML over here, but trust me, if you would try to do this yourself without open function, you would probably have 1,000-line YAML or something like that. So this might look intimidating, but it's actually very, very, very simple, especially compared to the alternative. Now, the question with this is, okay, you have this function that you want to run, but where do you run it, right? Where is the cluster where you will run it? It needs to run somewhere. Serverless still has servers. So the first question I will ask here is, where do we run this? How do we enable everybody in my organization to have servers or a cluster where this will run, and in a very, very easy way, right? Everything needs to be extremely easy. And the second question is, hey, if I'm using Dapr to connect to the database, where is the database? Who will create the database? And I want to enable developers to do all that, not only to deploy this function, but also to create databases themselves, to create clusters themselves, to do everything themselves in a very, very easy way. So 3 questions, actually 2 questions for now. Where is my cluster? How do I create it? And where is my database? How do I create it as well? And so you can think of today's session as a demo, hands-on demo. I don't like slides much. That will show you very, very quickly how to create cluster as a service, how to create database as a service, how to create application as a service, give it all to developers to do it themselves without knowing the details about cloud or the Kubernetes or anything like that, and to make it all very, very secure at the same time. So let's start with the database as a service, right? Here I have one definition, one YAML that will enable people to create that cluster themselves, right? Now, in this case, I'm using Crossplane. And what is nice about Crossplane is that you can define anything you want. This interface, this YAML, this definition does not exist in Crossplane. I created it myself as an ops person, right? And here I'm saying, hey, if you're a developer, you can create a cluster yourself by specifying those things. And you start by saying, where do you want this cluster? Do you want it in Google Cloud or Azure, or in this case in AWS? What is the type of the cluster you want? What are the size of the nodes you want? You don't have to know what is the exact sizing in AWS or wherever you're running. You just say medium or small or large. How many nodes you want? What are the namespaces you want in that cluster? Would you like to have some applications installed in that cluster? Like in this case, I want open function and I want external secrets. And how to propagate the secrets from the management cluster where I am right now to the new cluster, right? I'm going to use external secrets operator for that. I'm going to use secrets manager in Kubernetes, sorry, not in Kubernetes, in AWS. Your users do not need to know any of those things. They just need to specify what they want, and then things will automatically happen, right? Now, the way all that happens is that I designed myself for my users, for my developers, what we call Crossplane composition, that you can see the marketplace here, and you can see all the documentation, you can see how it works and all that stuff. I don't have much time to go into the details. Here, I have the link to the slides, so you can reproduce everything I'm doing myself. What does matter is that I can apply this. Now, normally I would push this to Git and let Argo CD do the magic, but I will not do that today because I don't have enough time. Instead, I will say, hey, kubectl namespace is my team in this cluster is a team, and I want to apply what I want to apply, cluster AWS 2, right? I just push it to Kubernetes, and Kubernetes will figure out how to create a cluster. Now, a cluster in AWS is not an easy feat, right? You need a lot of things to run clusters there. And I can show you what's happening behind the hood by outputting all the things that I just created, right? So those 20 lines of YAML or something like that, behind the hood, behind the scenes, created all this, right? It created internet gateway, main route table associations, and routes and security groups and subnets and VPCs and so on and so forth. So all those different components from AWS and from Kubernetes itself, some resources that need to be installed, they're all being managed right now. They're being scheduled, right? Kubernetes expands that simple YAML into all the different components that are required. And you can see that right now it is working and trying to make it happen, right? Some of those things he cannot do right now because some other dependencies are required, but eventually it will become consistent and it will work. So now it takes around 20 minutes to create a cluster in AWS. I will destroy the one that I just started creating, and I will show you the same thing that I created yesterday, last night. This is the same definition, same YAML, just different name. And you can see that after a while, all that becomes eventually consistent. Let's see, there we go, right? This is the same components just done last night because it takes time, and you can see that all the AWS components and all the Kubernetes resources and everything was created, and right now it is managed by Kubernetes. So everything is Kubernetes today, right? Even if by Kubernetes it means it manages resources somewhere else. So my cluster was created, and I just that cluster contains like 30, 40 different components required for it, but users had to define 20 lines of YAML, and that's it, right? Let me connect to that cluster and show you that it's really working. This is a newly created cluster, and if I list the namespaces, you can see that that cluster is running in AWS. It has already Crossplane installed, it has Dapr installed, it has external secrets installed, and quite a few other things, right? You can see that, for example, the secret, where is it, right? The secret to connect to the database was already created in that cluster. The secret how to connect to the secret store, to the container registry to push images is created. Everything is ready, right? And I just need to have to define 20 lines of YAML instead of 1,000 or something lines of whichever language you might be using yourself. So that cluster is ready for me to use to deploy applications. And I need to figure out how to create a database. Now, database is going to follow the same pattern. Cut db, there we go, db, here we go, right? Same logic. Hey, create a Kubernetes resource custom made for you, for your company. Call it SQL claim. Say, hey, you know what? Apart from a cluster, I would like to use AWS to create Postgres as well. This is the version, this is the size. I would like in that Postgres in AWS, which will be RDS, to have a database called MyDB. And I would like to have a schema. I would like to have those tables already created in that database and quite a few other things, right? And I can just apply that. Let's do that. Unset kubeconfig, going back to the management cluster, kubectl, namespace A-team. I want to apply something defined in DB AWS 2, right? There we go, ba-boom. And right now, Kubernetes is working, trying to create all the components required for my database with those 15, 20 lines of YAML or something like that. If I list what is happening behind the scenes, things that developers do not necessarily are interested in, you can see that, let's go. I said move, there we go, right? A similar story like before is happening, right? Kubernetes right now already created some things. It created route table associations. It created routes in AWS and so on and so forth. Some other things it cannot create because it needs to work harder a bit for that. But what matters is that all the different components, all the different pieces that are required for a database, and it's never easy, are being orchestrated right now by my Kubernetes cluster, no matter whether the database is in AWS or Azure or Google or wherever it is. Now this takes 10 minutes as well, so I will skip those 10 minutes and delete what I just created and show you the same thing that I created last night, so that you don't have to wait for it, right? And after a while, 10 minutes later or something like that, if you take a deeper look into what's happening, you will see that all the different components required to create a database are done. Again, I wrote only 10, 15 lines of YAML, not more. My database is created, and it contains the schema I need, the tables and whatever else is needed. It is security hardened. It contains the secret. It created a secret in the application cluster that allows applications to connect to it. It did absolutely everything, right? What did I want to do? Yes, now that I have a cluster and I have a database, let me go back to the application cluster, to the new cluster I just created, and show you go back to my initial idea. Hey, I want to enable people to create functions, right? To create serverless, to deploy applications as serverless applications. So going back to the YAML at the very, very beginning, this one, where I said, hey, I want you to take the source code for this repository, do whatever needs to be done with it, and don't ask me any questions, right? Build the container image, run the pipelines, deploy that as serverless application, use Knative, use KEDA, use Shipwright, use Argo workflows. I don't care what you do. Just run my application from that based on the source code in that Git repository. So, and now that I have a cluster ready, and now that I have database ready, I can just apply that. I can say kubectl namespaces production. I want to apply whatever is defined in function YAML, the one I just showed you, right? So 3, 2, 1, go. That's all I have to do. And behind the scenes, if you take a look at it, a couple of things are happening, right? If I list all the functions, you will see that right now the state is building, meaning that open function and all the tools that it covers, that it combines together, is right now cloned the code, checked out the code from my Git repository, and it is building a container image itself. There is no even Docker file. There is nothing but source code of my application. It took that source code, it figured out that it should build as Go application, as a container image or a Docker image, and right now it is building it, right? And now this will take approximately 30 more seconds just for me to take a sip. And once it's finished, you will see it up and running, right? And it will be up and running. Well, that is happening actually. Let me prepare something. I will there we go. I'm going on a different screen. While it is building, I'm going to go to this tool to do some performance testing to prove to you that it is running. So I'm going to bomb my application with tens of thousands of requests later, once it's finished building. So let's see whether it's finished. Come on, still building. You know, this is a proof how you get so spoiled over time, right? Like 20, 30 years ago, right? When I was still relatively young and junior in this industry, if my application would be running in production the same day, I would think, oh my God, this is so amazing, right? Now I get impatient because it takes more than 1 minute to build my image. Okay, there we go, right? Now you see that the build state is succeeded, meaning that it took the source code, it built a container image, it pushed it to the registry, it authenticated to that registry using the credentials that were created by Crossplane earlier, and right now it is starting the application, right? It is creating it, starting to run it in my cluster, and if I show it again, it's still starting. It will soon run. And while that is happening, I will take a quick look at this will be the address of my application, open function demo production, what's or not. And let's see whether it is running right now. Yes, look at that. It's running and it's available for me, and it's connected automatically to the database, even though I did not configure anything, even though I didn't do anything. My code does not even know that there is a database. And if I send a request to the application, and from that application to the database to put something in a database, it should work, hopefully. Come on. If my demo fails at the very last moment, I will be very disappointed. There we go. It worked. It put something to the database and it retrieved something to the database. So my application is running and it is communicating with the database I created a few minutes ago. And I can, let me take the URL. Here is the URL. I will try to see what happens if I send it requests. I will do this. I will say, hey, you know what? Send 5,000 requests to the application. This is, by the way, DDoSify, which is a very cool tool. And do it from Europe and from, let's say, Asia. Why not, right? This is nothing to do with the subject I'm talking. I just want to bomb my application from different parts of the world to see whether it works. And I will call that test. And there we go. Now requests are going in, right? You will see the number here increasing. Cool. It will send 5,000 requests to my application just to prove that it works. And while that is happening, if I say, hey, is my application really running? And you will see that there is one replica of my application. One pod was created because at this moment, Open Function and specifically Knative, which is part of it, thinks that one replica of one instance is enough to serve all the traffic, right? And soon, within probably half a minute or something, it will realize that all those requests that are coming into my application, you can see them here, it's going towards 5,000 requests. Soon it will scale up automatically. Let's see whether that is happening. There we go. Look at that, right? Automatically, it figured out that having one replica is not enough for this amount of traffic. And it automatically increased the number of replicas to, what is it? 1, 2, 3, 4, 5, 6, 7, 8 replicas of my application, right? So it scales up and it scales down, and it can scale down up to 0 replicas. And you will see that in a second, right? Let's see what's doing. Okay, I'm going to let it run. In the meantime, let me show you the source code of my application. First of all, actually, if you take a look here, there is no Docker file. There is nothing really. There is some clutter that is not related to this talk, but there is no Docker file. There is nothing. The only thing that exists here is the code of my application, which matters here is the video.go. And now I will not teach you Go today. That I would not have time in the last 5 minutes. But what I will tell you is that this is the source code of my application, and it does not even, I never even told it where is my database, how to connect to the database. That's what Dapr is doing. All I'm saying here in my code saying, hey, you know what? Connect to something, I don't know what, and use Dapr, and Dapr will tell you how to get to the database, where to find it, how to authenticate. Don't ask me questions even from the source code of my application. Figure it out yourself. You're a big boy, you can do it, right? Now, let's see what's happening with the pods of my application. You remember how there was like 7, 8? It increased number of replicas to 7 or 8. Now it went back down to 1, right? Because now the traffic stopped flowing into my application. The users stopped sending requests. So it says, hey, why would I waste resources in your cluster? I can scale to one replica, and if I go back again, you will see that there is nothing now. Now it's scaled to 0, right? So it will oscillate between 0 and any number of replicas, depending on how much you need. And I think that I have only 5 minutes left, give or take. No, I'm over the time, right? Same. Did I messed up? I'm not sure. I probably have 5 minutes for questions, right? So let's put the slide here. There we go.
Yes.
Thank you all. I expect you to give me some questions. Do something. I work for Upbound and Crossplane. I did not even introduce. Maybe Saim introduced me. I'm not sure. I have a podcast. If you want to listen to it, go for it. There is a QR code. I'm going to give you 5 seconds. 1, 2, 3, 4, 5. There you go. There is a book. If you send me a message on Slack or Twitter or LinkedIn, I'll give you the code for a book for free. All of you. And there is a YouTube channel as well. And you have the slides. You have all those QR codes yourself. Saim will give you the link to all the slides if you didn't have enough time to get the links. Thank you so much. Are there any questions?
Yes. Okay, for Viktor, let me check and ask a question audience live today, and I will get back to you. Give me a few minutes before we
Sure.
go. Sure.
Anything.
Any question for Crossplane? Yes. So, Viktor, we have a question for the audience. What causes the pod to restart while when we are scaling?
Oh, I just went to my application. The code of my application is intentionally bad. So I made the code so bad that it opens a separate connection to the database for every single request. And I made it so that I can demonstrate some bad features of my code and things like that. So it opens more connections to the database than database itself allows. It's intentionally bad code.
Okay, got it. Can this orchestrate AWS Lambda functions?
Yes, it can orchestrate anything in AWS, anything in Google Cloud, anything in Azure, and many, many other places. You just install providers. We call them providers in Crossplane. And depending on the provider, you will extend, each provider extends Kubernetes with new custom resource definitions and new controllers. And you just use them as you would use any other resource in Kubernetes.
Okay, so I think we have 2 more minutes left. So is any more question from the audience? Does it support that? Viktor, does it support any RBAC kind of capabilities or rollback-ins if stuff goes wrong?
Great question. And it does, but it does not matter. And here is why it doesn't. Crossplane, assuming that the question is about Crossplane, it is Kubernetes native. And that means that you can combine Crossplane with any other thing running in Kubernetes, right? So you can create policies with Kyvern or Gatekeeper. You can use RBAC of Kubernetes itself, right? Or you can use some RBAC of some third-party solution. You can use GitOps with Argo CD Flux and so on and so forth. The beautiful thing about Kubernetes is that you can combine everything with anything else that is Kubernetes native, right? So we don't have to build our own ecosystem like some other tools. We can just say, hey, we are Kubernetes native. Anything works with anything else. And that's a beautiful thing about Kubernetes. So yes, RBAC, yes. There are dozens of tools to do RBAC in Kubernetes.
Yes, absolutely. Thank you very much, Viktor. It's been a pleasure talking to you today and actually joining. One more question. Is this supported on bare metal on-prem services?
Yeah, you have providers that, depending on providers, you have Equinix Metal, for example. I know that it's supported. You would need to go to, I don't use Metal myself much, so go to the marketplace.upbound.io and you will see the list of providers. And if whatever you need is not supported, it's very, very easy to create your own provider to add the things that are not supported.
Okay, great. I think we're run out of time. Thank you for joining, Viktor. It's been a great talking to you as well. I will connect to you back to soon as well. Thanks for joining us on the K8s event, and we'll meet soon. Bye-bye, Viktor. Have a wonderful day.
Thank you for having me.